Okay, today we do some sample question and revision of chapter 1 for projectile motion. So we go back some basic principle that we had learned before, and how uh, by this sample question we will go through the equation of trajectory and something that we uh, did not mention very clear at the uh, first part. So we just go through some of the things. Okay, a projectile motion, as you know that you know that for projectile motion, this is a quadratic graph. You already know, and so this is the symmetrical line. So the total time for this, let's say from here t0 to t1, right, is a total time t0 to t1. So at the center part here, the t will be equal to t1 minus t0 divided by 2, and you know that. So there are a situation that you need this common knowledge to in order to solve the question. So in order to apply this principle, we go back to the very basic equation that we have learned before. So for the vertical component of velocity, we have vy equal to u sine theta minus gt. The gravity is face down, so you either move up first. So we follow the direction of movement, so you have a negative g. So let's say we at the maximum point, meaning at the center point. Okay, so at the center point, the velocity will be equal to 0 because this is a turning point, right? So you can simplify your equation u sine theta equal to gt, because vy equals 0 at the particular moment, at the maximum point. So when you simplify this, rearrange, you have t equal to u sine theta over g, right? So this is the time for the item to reach to the center, I mean the maximum point. So from here you also can derive the total time for trajectory, or the total time for the projectile motion for a cycle from starting point to the and go back to the starting point position for the y. T will be equal to 2 times the time just now, right? So you also can derive like that, depends on what is the application in your question. So, and if the question asks you to find the range, okay, the range, as you say, as the range will be the x will be equal to u cos theta t. So depends on the t that you want. If you want to find the total, I mean the range, the total distance, horizontal distance, the travel, you just put this t inside. If you want to find the horizontal distance that you have traveled at the center point, you just put the t as u sine theta over g. So depends on the situation. So for this, the range will be equal to u square sine 2 theta over g, right? So this is the things that you have derived before. So now we will see how to apply this formula in example 1. We go for question 1, sample question 1. Okay, for sample question 1, a particle, sample, for this sample question I will put as 1 2. Okay, 1 2 in the chapter 1 2, if you look at the upload documents. So for question 1, a particle is projected from a point on the horizontal surface with the initial speed of u20 at an angle of elevation of 25. Find the range of the particle. Okay, so for 1a, you know that, or you can direct apply the range. If you don't want to use this, you want to derive from the beginning, also can, no issue, right? So if you direct apply, the formula will be u square 2 theta over g. So you have 20 square psi 50 over 10. So if you continue to calculate, the range will be equal to 30.6 meter. Okay, for A. And B, the time taken to reach to the highest point. As you know that T will be equal to, highest point will be U psi theta over G. Right, so will be 20 psi 25 over 10. Right, so you will get T equal to 0.845. So this is the time for the particle to reach at the highest point. So if the question asks you the total time for the trajectory, so you will multiply by 2, then you will get the answer for the total time for the projectile motion. Okay, so this is very direct. And C, the speed of the particle when t equal to 0.5. C, so you have the horizontal velocity equal to 20 cos 25, right? 20 cos 25, right? So you have about 18.126, and you have a Vy is equal to U plus AD. So the AA just turns to negative. Okay, so and you will get about 3.452, right? So you can use the exact value directly, and you will find the speed is equal to square root of Vx square plus Vy square. So you can put the exact value, you will get a better answer. Okay, so the answer will be 18.5 meter per second for C. Okay, question 1. Okay, now we look at the question 2. Question 2. A particle is projected from the top of a platform 50 meters above the horizontal floor below. Okay, so the angle of projection is 45, and initial speed is 25 meters per second. Fine. A, the exact time taken to reach the horizontal floor below. And B, the exact speed of the particle and it hits at the floor. So and this projected, you start from the 50 meter above the horizontal floor. So now you want to, depends on your reference point. So this question, so normally we will take the initial position as a reference point. Okay, so if you want to find the time to hit on the floor, so the displacement for this situation will be negative 15. So you have you will use the vertical component, negative 15, okay, equal to ut, and minus half at squared, half 10t, so must half 10t minus 5t squared. So when you rearrange this equation, you will get a quadratic equation similar like t squared minus 5 square root 2t minus 3 0. So when you have this or you may not simplify the sine 45, depends on you. Okay, so if you want to put insert form also can. So as normal, this you have to show how to solve it. Okay, so once you solve it, you will get t equal to 3 square root 2 second. Right, so this is for the T. For B, the exact speed of the particle as it hits on the floor. So you want to find the speed, but you know the time already. So we have a Vx, the horizontal one equal to 25 cos 45, this one constant, right? And C, you want to change to third form or not? If you don't want, you can keep in this form. Vy will be equal to 25 sine 45. Okay, plus 80. So the A you can change to 10, negative 10. Multiply the T just now. Okay, so and you can put this value direct inside the V equal to Vx squared plus Vy squared, right? So simplify, you should get 5 square root of 37. Okay, so for this question, if the question did not mention you must put the answer in short form, you can, if the question then mention right, if question mentioned exact speed, so your answer must be in the exact value. If the question not mentioned in the exact value, not exact speed, you get in the decimal. So be careful about this, alright? If not, then your final answer will be deducted 1 mark. Okay, so this one for question 2. Okay, before question 3, the previous example, all we projected in this way, up and down, right? This way, okay? The previous example, but there are the situation you can project it downwards. This one projected upwards. So if you projected downwards, you will have something like that. So projected downwards means you same things. You have a height here, you have the y height here, and you have an initial speed here, and you have an angle here. The way to solve formula same. The only one thing is the A you must be careful. The vertical A, the gravity. So you see where at the if you reference what is the initial position, when you project it downwards, your direction of movement is the same to the gravity. Okay, so same to the gravitational force means for this kind of analysis, you need to consider the A as positive. So all the previous equation you can use, but if the question involves the G, you must change to positive. So because the direction of movement is the same to the direction of acceleration. Okay, so we will see what happened for the next question, right? Question 3. Okay, question 3. An aircraft is on scientific data collection mission over an ocean. The aircraft is traveling horizontally at a speed of 50 when it launched a sensor at an angle of 25 below the horizontal with an initial speed of 10, given that the plane is 1 km above the ocean, and assuming that the ocean surface is flat. Find the speed of the sensor when it's 100 meters from the surface of the ocean. Okay, assume that the air resistance is negligible. Alright, so now you have okay, plane is 1 km above the ocean, so you want to find the speed 100 meter from the surface of the ocean. So means the vertical distance that you have traveled by the sensor is 900 meter. So you can put 900, question 3, 900 meter, and is equal to don't forget this time, okay, you need to use the ut plus half at square equation. So the vertical speed is a 10 sine 25, 10 sine 25, and plus half at square, and now is positive because the direction of movement is the same to the gravity, right? The direction is the same. So in this situation, okay, the important part is here, positive. So by doing this, you can simplify the equation, become t squared plus 2t sine 25 minus 180 equal to 0. So by simplifying this and solving this, you will get t equal to 13. So this is the time taken for the sensor to reach to the target point, right? So question is asking you find the speed at the particular moment. So means is a resultant speed or is a total speed. So for this situation, you need to find the vertical speed. Vy is equal to 10 sine 25. Don't forget this one plus at. So you can put in the exact value, but before you calculate, and Vx will be equal to the aircraft fly with 50 horizontally, and the projectile with the additional velocity 10 cos 25. So the speed that you have, the velocity, horizontal velocity that you have is 59.06. Okay, so this one you can put in exact value and direct put inside here. Right, so you will get 147 meter per second. This is the resultant speed. Okay, so for this example, you need to consider when an object is projected with an angle of depression. Depression means the angle projected downwards. Okay, so as this situation, because the downward motion is the same to the gravity direction, so this means your vertical displacement is positive and the value of A is also positive. Okay, so this one for question 3. Okay, so before we go to question 4, we just do some revision on the general formula of the trajectory. Okay, projectile motion. So if you look at the notes before, you have this. Okay, so you see the negative here, the G with the negative there means this one is projected upwards. Okay, so if you have projected downwards, this one should change to positive. Be careful, okay, when you use this formula. So this formula you can find it in your formula booklet. Your formula booklet should be x tangent theta minus g x square 2u square cos square theta. They are same, right? So this is the things. This is the equation that you may use, but it's not compulsory to use. But they are the question that ask you to use, so then you have to use. Okay, from the trajectory equation, let's say when y equal to 0. Okay, so you can simplify your equation become x tangent theta minus gx square 2u square second square theta, then is equal to 0. Okay, extract the x out, you have the tangent theta g second square theta equal to 0. So when y equals to 0 means either is at the starting point or at the end point. So you can extract this part out. So you have tangent theta is equal to g 2u square secant theta. Okay, so for this question, equation, if you rearrange this, sorry, here still have one x. If you rearrange this, you put x in terms of theta and g, you will get u square sine 2 theta over g. Right. So you go back to the range equation. The range equation. So I mean, for this chapter, you can play around on all the unknown equation, play around. So don't have things to fix you. So you no need to memorize. Okay, so you can play around from the beginning. Right? So I don't ask you to memorize, but if you think that you can remember and you can use it faster, I have no issue. But for personally view, if you can derive, you don't need to memorize. Okay, right, now we go to question 4. Okay, question 4. Question 4. A projectile is launched from a point O, 1 meter above the horizontal ground level. It is given that an initial speed of 20, angle of elevation of 25. Find the horizontal distance from O when the particle is 2 meters above the ground and descending. Alright. So this question, if you want to use the trajectory equation, and you may assume that the question is asked you to find, is given that find the horizontal distance of O when the particle is 2 meters above. Okay, so now if you take the originally is 1 meter above the ground, and then after a while is 2 meters above the ground. So the difference between the displacement is will be the 1 meter. So for this one, you may direct put inside the trajectory equation, x tangent 25. Okay, this one projected upwards. So everything put inside the 10x square 2 times 20 square, then secant square 25. Okay, so solve it. You may have you rearrange this. You may have secant square 25 AD x square minus x tangent plus 1 equal to 0. Okay, solve it. You will get x equal to 2.32 or 28.3. As this question is projected upwards, and they ask you to find the descending distance, means the larger one, because already go up and down already lah. So answer is x equal to 28.3. Right, so this is the answer for question 4. Okay, I think should be okay, right? Right, so we still have few questions. We will continue next class. I will pose a question for you to solve, and please try and go and try it. Thank you.